Here is a question from nuclear physics which was asked in CSIR NET December 2024. Here we have to find the binding energy of polonium-210 and lead-206 and the Q value of alpha-decay of polonium-210. And we are given some data. Mass of proton is given, mass of neutron is given, mass of polonium-210 is given, mass of lead-206 is given, binding energy of helium is given, and the conversion factor from atomic units to MeV upon C square is given. To solve this question, you need two formulas. If you know these two formulas, then this problem is only a problem for calculators. You have to substitute the values correctly in the calculator and then you will get the answer. So what are those two formulas which you need here? One is the formula for binding energy. Binding energy is equal to ZMP. Z is the atomic number and MP is the mass of protons, plus A minus Z, this is the number of neutrons, times mass of neutrons. So when you multiply mass of protons by the number of protons and mass of neutrons by number of neutrons, you will get the total mass of constituents. Total mass of constituents is obtained. Now the total mass of constituents, it is always greater than, a little greater than the mass of nucleus, and this is called mass defect. There is a small difference between mass of constituents and mass of nucleus. This defect in mass is called mass defect. Mass of constituents is a little greater than the mass of nucleus. And when you multiply mass defect by C square, you will get the binding energy. So this defect in mass, it is converted to energy, which is called binding energy. And binding energy is defined in two ways. One is, it is the energy released when neutrons and protons combine to form the nucleus. Another definition is, it is the energy required to disassemble a nucleus into its constituents, which are protons and neutrons. So this is the first formula that you need to use here. Another formula we need is the formula for Q value. Q value is defined as initial mass minus final mass times C square. Now we know the formulas. Let's do the calculations. First we need to calculate the binding energy of polonium-210 84. So binding energy of polonium-210 84 is equal to Z times, Z is 84, times mass of proton, which is 1.00. Mass of proton is 1.007825 atomic units. 7825 atomic units. Atomic units can be converted to MeV upon C square by multiplying with 931.99 MeV upon C square. There is a C square outside in the binding energy formula, which is this C square. And then we have A minus Z Mn, which is 210 minus 84 times mass of neutron, which is 1.008665 atomic units. 1.008665. And finally we have mass of polonium-210, which is to be subtracted. Mass of polonium-210 84 is 209.982876. Two 9.982876. So when you do this calculation, you will get this approximately equal to 1646 1646.09 MeV, which is very close to 1645.21 MeV. Now similarly we can calculate binding energy of lead 206. It will be, if you calculate this, you will find that it will be equal to 1623.2 MeV, which is approximately 1622.33 MeV, which is given in the options. So 1622.33 MeV, this is correct. Now for Q value, we have the relation initial mass minus final mass into C square. This is equal to, in the case of alpha decay, we have the relation polonium 210 is decaying to Pb 206. This is 84, this is 82, plus helium 42. This is the equation for alpha decay of polonium 210. Initial mass is mass of polonium 210 and final mass is mass of lead 206 plus mass of helium 42, and you have to multiply this whole thing by C square. Now mass of helium is not given in the question. In the question there is no mass of helium given, but binding energy of helium is given to be 28.80 MeV. But we can get the mass of helium. Mass of helium is equal to, we can use the same formula for binding energy. You can use this formula, rearrange and get the mass of nucleus. So therefore we can write mass of nucleus of helium 42 is equal to 2 times Mp, this is Z, plus 2 times Mn, this is A minus Z, this is Z, minus binding energy divided by C square. Now when you put the value of Mp, Mn and binding energy that are given in the question, you will get mass of helium 42 approximately equal to 3729.8 MeV upon C square. You have to put this value in this equation. You have to put the value of mass of helium 42 and also substitute the mass of polonium 210 and mass of lead 206 here. Then you will find the value of Q approximately 5.9 MeV. Therefore the correct option here is option 1. The binding energy of polonium 210 is 1645.21 MeV and binding energy of lead 206 is 1622.33 and Q value is 5.92 MeV. Thank you for watching this video. If you found this video helpful, please subscribe to the channel if you haven't done it already. Thank you.